In today's tutorial, we are going to look at the new Point Relax tool that I just released on Patreon. The Point Relax tool allows us to distribute points on a surface and also such that they maintain a certain distance to one another. So in this particular setup here, we start with a sphere and then we add some noise to it, use a normal pop to generate proper normals on the sphere, as we can see here. And then I sprinkle some points on that sphere. And then we start a small feedback loop that really just contains two different pop operators here. The first one being a noise, the effect of which you can see here if I turn this off. So the noise just pushes those points around on the surface, while the point relax forces them to stay on this ever-changing surface and to maintain a certain distance to one another. So if I skip the point relax, you will see that those points can just fly off to wherever they want. And if I reintroduce the point relax, they are forced onto the surface. I then copy small spheres on each of these points, and then I render both the points and the surface itself using a small default, really easy render pipeline. Okay, so this is what we are going to recreate from scratch so that you can follow along. I will delete everything but the point relax because we'll definitely use this in a second. Okay, so this is all going to be based on pops. So if you want to work with pops or follow along, you need to download the newest experimental version. So as I said, we're going to use a sphere as a starting point. Let's set the frequency to 15. So we have a decent number of triangles here. I will then use a noise to deform this. I will make it such that my node viewer is on by default. So I will deform the sphere a bit, a little bit stronger than this, but also a little bit more structured. And I'm going to go to the output tab of the noise pop and turn off the noise output, as we don't need this, and set it to translate along normal, which yields this, well, a little bit smoother distortion of the sphere. I will then add a normal, oops, not the normalize, but the normal pop to generate smooth normals again. And then, as I said, I'm going to use a sprinkle pop to generate some beautiful points on that sphere. Let's start with 5,000 points and have a look at this later. For some reason this connected to my point relax, but I don't really want that. From here I want to create a small feedback loop. Or maybe for understanding, let's first go to the rendering side of things. So we will, whatever these points are or wherever they are, I'm going to copy them, or rather I will copy a sphere onto these points. This sphere should be way smaller, so let's give it a super small size and copy it onto the spheres. We can set the size again later, and then I'll just use a geometry node and connect it to the normal pop to then render the surface, and also connect a geometry node to the copy pop to render those points. And then we can go along and use a render top. And that's resolution. The resolution I will set to parent.project.width, such that it will take, and .height, such that it will take the width and height from my project level. So there's a certain width and height defined here, which I define as monitors 0.width and height, such that whatever I do in TouchDesigner is always rendered at full screen resolution. Yeah, so this is going to be our render top. Obviously, we will need some camera. I will actually use some arcball camera of mine, which you can also find on the Patreon, which has this funny dolly zoom effect, and I introduced a small lag here. I will show you this in a second. Let's attach an output, top, and a light, which I will put somewhere, and maybe I like to parent the camera to the light such that the light follows my camera. And as you can see here how I move my camera, but the movement is lagged a bit such that it's not so steady and not so yeah, this is how it looks like without the lag, and I oftentimes find this a little bit unpleasing because it's so abrupt, and using the lag I can smoothly move around. Okay, well, now we are rendering the surface and the points. Let's use some material actually, because this looks not so pleasing. I will choose some color maybe for those points, and I should potentially increase the light brightness because we're working with PBR materials, and also use a PBR material on the surface, which I actually kind of like to be a little bit darker. So maybe let's dim down the base color. And here I don't like the red tone. I don't know. Let's actually stick with white and make those spheres a little bit bigger. Maybe like this. Okay. Now we want to move those points in space. So, actually on the surface. So let's introduce a feedback loop where we update the position of the points in each feedback cycle. So I'll use a feedback and a null, and then I drag and drop the null onto the feedback as the target pop. And I will use a noise, which will immediately move those points through space. This is far too quick for me. I will set the amplitude to be 1/me.time.rate, which is going to be 1/60 in our case, because that's my FPS. So if I reset the loop, this is rather the speed I'm looking for. I will also translate the noise in time using me.time.seconds times 0.01 or so, or 0.5. And then I will not output the noise attribute because I'm not interested in that. And I will maybe set the combined entity to be the curl 3D. Okay, this is still really quick, so let's actually set the amplitude to something smaller. Here we go. And yeah, I will definitely reset the feedback loop every now and then. So I will set the start of it to be me.time.frame equals 1. So whenever the timeline goes to 1, this will reset the feedback loop, and I do have a customized shortcut to set Shift R to reset my timeline. Okay, so now my points are still flying around in space, but I'm going to use the point relax to force them onto the surface. This is actually quite simple. I can just connect those points as the first input, and the surface I want them to be attached to in the second input. And then let's have a look at how that looks like. And here we go. They are a little bit jittery sometimes if they actually feel a too strong force that actually pushes them together, and then there's another force that also drives them apart from one another, and then they will jig around like this. So maybe we can reduce the strength of the point relax such that they are still not getting too close to each other for our liking, but also don't jig around like this. I forgot to animate the noise of the sphere, so let's go here and also write some expression, which is going to slowly move the sphere, or this blob, around in space and deform it. Yeah, and I'm quite happy with this. This is more or less what I was looking at. I think I potentially also went over to the light and set it to be a cone light, and then use soft shadows on it, potentially with a reasonable shadow resolution and some proper values on the shadow, such that the light can cast shadow on the object. I'll move it around a bit. Yeah, oops. Yeah, maybe this looks more interesting, I don't know. It's up to you to make it look good. I just want to show you how to do it. In this particular case, maybe we'll do a look tutorial another time. Yeah, so this is already pretty much what we wanted to achieve today. I will show some other things of the point relax maybe. So the point relax has 4 parameters. The first one is number of iterations, and this will just get more expensive the more iterations we use, but also more stable. So as you can see, I reduced the number of iterations to 1, and now they jig around. But this still takes 2.5 milliseconds, so you should note that the point relax is not a cheap operation, because each point needs to loop over all primitives in the second input for each frame. So if I set this to 4, this gets stable, but also takes 9 milliseconds, which is quite expensive for an operation in TouchDesigner. We can also set the number of neighbors each point should look at. And again, if I set this value lower, the simulation might get less stable, although we can barely see a difference here. But it also did have a big difference on the performance. And if I increase this value, it will probably get a little bit more stable. Well, this didn't change much with respect to our performance yet. Okay, in this example it seems to be somewhat irrelevant. The distance will be relevant and decides on how far those points are, the distance these points are trying to relax to. And the strength is, of course, like how strong they will be pushed towards each other, away from each other. Okay, so these are the parameters, and what I also wanted to let you know is that if we don't give the point relax a second input, so if I disconnect this, the points will just relax and like move away from each other in 3D space, while if I connect this, they will also follow the surface. And maybe another thing I should tell you is that within the point relax, there's another handy tool that I will also drop on Patreon independently, which is closest point. And this just also takes some point cloud. So let's use a point generator. Let's use a circle. So here we have some points on the circle. And let's use torus maybe. And the closest point will calculate for each point on the first input, the closest point on this second input, so the surface I provide. Maybe I should set this to be in this plane and maybe move it upwards. And it's currently set to project those points onto the closest, but if I don't do this, but rather, for example, connect those two, you will see, let me move them further up, that for each point here, we have a little bit too many points to see something. For each point in the input, it will calculate the closest point on the surface, when it's not only calculating the points here, but also if the closest point is somewhere inside of a primitive, so inside of a line, inside of a triangle, or inside of a quad, it will consider that to be the closest point. Let's merge this with the input torus, and you can see how they all found their closest point on that torus. And we can choose if we want to connect those points, or if you don't connect them, you will just find that each point gets a new attribute called closest, which is a 3D float, so a position in space of that closest point. And we can also decide to project them, so those points will just directly be moved onto that surface at their closest point, or we can choose to connect them. Okay, yeah, this is what I wanted to tell you about the closest point tool. And yeah, this is about it. Thank you for watching, and as always, I'm looking forward to seeing your creations. Have a good one. Bye.